Okay, let's do another example where we are solving with our table. Example 2b. And let's solve 5x squared plus 30x plus 14 equals 2 minus 2x. Again, similar to our last problem, this equation is not in standard form for a quadratic equation. I need my equation to equal 0. So I will add 2x to both sides and also subtract 2, giving me 5x squared plus 32x plus 12 equals 0. And similar to our last problem, I don't necessarily want to try to factor this. Maybe it will, maybe it won't. I don't know. So let's use our graphing calculators. Let's use our technology. Okay, right now I'm in my table from my last example, and it's sometimes helpful to go back to your table set and to change this delta table back to 1 so that our table is going up by ones. Okay, keep in mind I want to find when is my y value 0. And I see one situation right away, when x is 2. Okay, that's one x-intercept, but we might have a second. So let's look. Okay, going down, my y values get bigger and bigger. Going up, my y values get smaller. We hit negative 33. We hit negative 33, but then our y values increase again. So somewhere between negative 1 and somewhere between negative 2 and negative 3, we yeah, it would help if I actually, put in the right equation for my situation. Again, my next step to get my equation into my calculator so I can look at the table is to go to y equals and type my equation in. 5x squared plus 32x plus 12. This will help me find the x-intercepts of the function, which really, again, is our solution to our quadratic equation. So I type this in and I go to my table. All right, now my table, I already changed my table set back, but if your table is going up by tenths here instead of by ones, we have to go back to table set, second table set, and we just want this delta table to be 1. All right, so make sure you make that change. That'll make looking at your table a little bit easier to start off. Okay, let's find our x-intercepts now. Well, right away, I know I have something in between negative 1 and 0 because I go from a negative y value to a positive. So somewhere between negative 1 and 0. All right, well, let's go to my table set again. And if you saw this before you change your table set back, sorry for making you do some extra work. I'm going to change this to halves. Go back to my table. All right, well, somewhere between negative 0.5 and 0 narrows it down a little bit. Probably a little closer to the negative 0.5 since my y value's not too far away from 0 here, further away from 0 here. All right, back to table set again. Let's change this back to 0.1s. And, oops, now I have to scroll a little bit more. Right here, negative 0.4 is one of our solutions. So x is negative 0.4. Let's see if I have another. Okay, I'm going to change my table set back to 1 because this helps me scroll through our y values a little bit better. Okay, now as you can see, this is 1.7, 2.7, and all that stuff. Back in my table set, let's change table start to 0 and then going up by ones. So that'll just make it so every x value is a whole number. All right, scrolling down here, my y values get bigger and bigger and bigger. So that's my clue. I'm going the wrong direction. And we already found the intercept between 0 and negative 1. Now look at my y values here. I have negative 32, negative 39, negative 36. So I'm getting more and more positive now, which means I'm getting closer and closer. Here's our other x-intercept when x is negative 6. There are two x-intercepts, our two solutions to our quadratic equation.